everyone, my name is Krithika and my data science capstone project is on e-commerce customer churn prediction. In today's digital landscape, e-com has transformed the way we shop. We have got from online retail shopping to the grocery delivery at our doorstep nowadays. However, with convenience comes a challenge as well. So that is the customer churn. What actually is customer churn? It's a silent drain on companies where customers either leave for competitors or gradually disengage, which could negatively impact the revenue and growth of the company. So even industries like Amazon and eBay, they face the constant battle of retaining their customer bases. So in real world example of churn in action, I personally used to engage a lot in online shopping. Sometimes I get frustrated with poor customer service, high shipping cost, or the lack of fashion. So I tend to explore other options as well. So this is the scenario in the e-commerce industry daily on a daily basis with many different customers like me. So which could contribute to the increased churn rate. So that's why it's important to take measures at the early stages. So when we aim to retain a customer or increase the turnover in business, we have to utilize certain strategies such as like providing them with offers, discounts, and coupons. So ultimately, how do we know that what to do? It's by predicting the data using the machine learning techniques and building the models, even the data analytics team. So this is what like the data scientists do nowadays. So coming to the project, like just like other data scientists, I followed the same strategies of collecting the data, did some basic cleaning before my EDA, and applied the machine learning model techniques, and did the evaluation based on the results achieved and predicted whether it is a good or a bad model. So these are the steps I followed in my project phase. So coming to the data set. I took a data set from the Kaggle, which is for one particular e-com industry with a year period of data collected about their customers. So we have here, if you see, we have 5,630 instances and 20 attributes, which are going to be useful for our model prediction. We have got total of 6 categorical variables like gender, marital status, payment method, etc. Also, our target variable for prediction is the churn column. So this is a target variable prediction. So like that whether the customer is churned or not. So the next is the cleaning phase. So in my cleaning process, I did very basic data cleansing like checking missing values or any presence of null input. So the bar plot here, it shows the percentage of missing values for each attribute. So I have filled those missing values with the median calculated. So also check the data redundancy if any duplicates are there and the data imbalance with respect to the target variable. So when I observed there was slight imbalance in data but not a major issue here, but just to explore on the SMART technique, so I have worked on the data imbalances too. The next is the EDA. So in my exploratory data analysis, I tried all these approaches like on my data. So I visually distributed the data, performing the univariate analysis, bivariate, and multiple variable analysis through the heat map. I wanted to explore feature engineering as well. Hence, I try to create new features like has spent on app order count ratio and the recent coupon usages. So these are the two new features which I did on feature engineering from what I have the data with, so that I can do some feature selection in my model. There were outliers on certain variables, and hence I used z-score method to remove the outliers, and finally I did analyzed on the feature importance too. So if you could see the univariate analysis here, like these are the categorical variables we took, and if you could see the preferred order category, so the churn rate is high for the mobile phone category when compared to grocery. So it could see like people do grocery shopping a lot, so there are no chance that people reduce their online shopping on groceries. And then even if you see the tier cities, like we have the tier 1, tier 2, tier 3. So in that, the tier 2 city people, they likely to churn less because they are like have the habit of having the luxurious shopping or whatever it is based on their economical conditions. So these are some of the observance which I could see from the plot. And in the bivariate analysis, I have plotted with the gender and the marital status against the churn rate. So if you could see, the churn rates are high for the male category than the females. And if you see the marital status for single people, so both female and male are in the highest range. In that, even the male are topping the chart. So also this plot is on has spent on the app and the satisfaction score against the churn rate. So if you could see, people who tend to use the app less than an hour or two, yeah, less than 2 hours, so they never churn. Like if you could see this report, so the first 7 bars or 8 bars or something, like I have built these columns, so I'm taking the range of 0 to 1 hour, 1 to 2 hours. So in that, if you could see, the people who are using the app less than 2 hours, they, irrespective of their satisfaction score, they never churn. But people who are tend to use the application a lot, based on their satisfaction score rate, there is increase in the churn as well. So next is the multivariate analysis. So looking at the correlation heat map here, there appear to be some blocks of higher positive and the negative correlations between certain features. So if which could indicate the potential multicollinearity issues. So for example, the churn has a strong negative correlation between tenure. So it suggests that the customers who stay longer are less likely to churn. So on the other hand, the features like preferred order category. So if you could see, we have the preferred order category here. So even the preferred order category and the satisfaction score, they show a strong positive correlation. While multicollinearity, it seems to be present here. So further analysis we need to make in order to determine its impact on the model building process. So that's the reason I have done the feature importance. So I did the feature importance through random forest classifier. So it is helpful with that. I'm able to rank my features, like which all the features important in predicting the model. In that, tenure, cashback amount, warehouse to home are the top features which I have achieved in all three models. And in few in decision tree and other models, I could see like days since last order, a number of address, like there were little bit change in the features selected while getting the model results. So that's what I did feature importance, which is helpful for my model prediction. So coming to the machine learning algorithms, so I have used the techniques of SVM. This is the support vector machine, decision tree, random forest, and gradient boosting algorithms here. I have separated my data to train and the test, and worked on my trained data and calculated the accuracy and the AUC scores. AUC scores. So during the process, I have executed the classification methods with different hyperparameter values for each model fits. So this is like the basic the parameters, like this is the coding which I have created for the like grid search pattern. So in the grid search method, like I have given all the parameters for each models, and then based on that I am running the models on three values of the cross-fold validations. Like I set up the CV values to 3, 5, and 8, and I did the run for with all these parameters. So out of this, I could see that the results which we achieved for all the models with cross-fold validation 8 has got a better accuracy. And so this is the overall results we achieved for cross-fold validation value with 8. So if you see the chart, the gradient boosting classifier tops the chart, and so it has got a better accuracy than other models. Even the random forest has got good accuracy, but its runtime is higher compared to the gradient boosting. So we can say that gradient boosting is a better model out of all four here. So since I have tested the evaluation metrics and confusion matrix and the ROC curve for all the models, but since the gradient boosting tops the chart, I'm just showing the results of gradient boosting here. So if you see the evaluation metrics for gradient boosting, the confusion matrix shows a true positive rate of 88.14% and a true negative rate of 72.47. So the model achieved a precision of 0.75, a recall of 0.88, FN score of 0.81. So it is indicating like a good overall performance model. So looking at the ROC curve, the area under the curve is 0.90. That suggests the model has an excellent ability to distinguish between the two classes across different classification thresholds. So this is what is the result we got from the model evaluation on gradient boosting. So in this churn prediction project, we encountered several challenges as well. So dealing with the data quality issues such as like missing values, um, data imbalance, these are all the crucial things. The data imbalance nature of the target variable also with a smaller proportion of customers have churn, like it can lead to biased models. So and with 19 features in the data set, the dimensionality is challenging in terms of overfitting and feature selection. So overcoming these challenges was essential for building a reliable model. So that's what we have to see, like if apart from just using these models, we can go with neural network models or AI based testing, so that we will get a better accuracy score with handling all these values in a very advanced way. So that's what is I have learn from the research papers also. Like some research papers, they have taken the concept of using the neural network technique than going with just the normal gradient boosting methodologies. So also, though we have the promising results here, there are certain limitations too, such as the limited feature set as I spoke before, and lack of qualitative data and inability to capture the external factors. These all pose the challenges for this particular data set. Maybe for future improvements, we can just expand the feature sets. Maybe we can update the data sets, like instead of just taking a 1 year data, we can just keep having a history of records, so that that will be able to predict the model even more in a like a better way. And ensemble modeling techniques also could enhance the model accuracy. So by addressing these limitations and implementing continuous improvements, I believe like we can develop a more robust and reliable churn prediction solutions here. So that's all about my presentation. Any questions you people can post in the comment section, and I'm happy to answer that. Thank you.